Ethan Hunter.
And my name is Mike.
Welcome to our capstone presentation. My name is Ethan Hunter.
And my name is Michael Timmerman.
This is our 2D platforming game, The Silver City. Start with our motivation. For me, I got into programming to make video games. 6th grade, that's what I was doing. But as years went on, I was doing more advanced programming, more industry style. So when Capstone came along and I had the opportunity to make a video game, I jumped on that opportunity.
And then for me, one of the main reasons why I actually got into computer science was to join a company and create video games. So when I had the opportunity and the chance to create a video game myself and with Ethan for our capstone, I was thrilled and took it.
For our game, we used 3 main tools: Unity, Piskel, and Visual Studio. Unity is our main app. It is a wonderful app used by many people for game development. It has everything you need to create 2D and 3D games, although we didn't use any 3D. It has everything: tile sets, sprites, animation, movement, anything you could ask for, it has it, except for a code editor. That's where Visual Studio comes in. Visual Studio is a free app created by Microsoft. It's code editor. It's a decent code editor. Yeah. And third, last but not least, we have Piskel. Piskel is a free online pixel art editor. It's pretty bare bones. It does its job. It does it decent. For Unity, Unity codes in C#. C# is a coding language created by Microsoft to compete with Java. It is an object-oriented code design. It has a garbage collector. It's discount Java. But it has one saving grace here. Unity uses libraries and parent classes, and they both work wonderfully. As you can see in the code on the right, we have a class dialog trigger, which inherits from monobehavior. Monobehavior is the general parent for any script that is used by pretty much any class. It has plenty of parent functions that are overridden by its children. For example, start, update, or on trigger enter. These are, they're pretty self-explanatory. Start happens when the object is created. It's sort of a constructor or an onCreate. Update happens every game tick, which is the best way to check for interaction. For example, in this one, we check if the player is in range and pressing the key E. It means they can pick up an item. Or in this case, trigger dialog. Or we have on trigger enter. On trigger enter is triggered when 2 hitboxes collide, and 1 is marked as trigger. If this happens, well, in this case, it is cut off, but is in range is turned on. Or we have example key code or dialog. There are other classes handled by Unity, and they have methods that we need to use for key code. Example can interact with get key down. It's pretty simple and absolutely wonderful. But now into some game details. First and most importantly, we have a player. Player has a few simple controls and their key bindings. A and D move the player left and right. Spacebar is to jump. The E key interacts with pretty much everything: puzzles, items, doors, interactables, the whole game. Not listed, we have the left mouse click is the player's attack button. It will perform the attack action, as you'll see later. And we have the camera. The camera follows the player up to the edge of the screen. When the edge of the camera hits the edge of the screen, it stops. And for the player is animated. It has, as you can see on the right, a couple animations. It has an idle animation, a running animation, and an attack animation. So when the player, like us, the person, presses the keys down, the player object moves around and does the actions, and the animator takes those inputs and converts them to animations. So the state of the animator, each one has a separate animation that is performed. When the player presses the attack button, it transfers to the attack animation state, where it performs the attack animation and returns back to the state previous, which in most cases is usually the idle animation or the running animation. As you see on the right, the attack animation can only be performed once per click. If you spam click the button, can attack is turned off when you click it once. That way, the player cannot spam click and have the attack happen multiple times per animation.
And this is the code design for the player. So we have 4 different scripts attached to the player object, and we actually implemented a MVP design pattern with the movement script being the model, and the controller script being the presenter, and then our screen being our view. And so the movement script and controller script work together, with the controller script being responsible for getting the keyboard input from the user and then telling the movement script what to do with that input. So when the user pushes down on the D key, telling that they want the player object to move to the right, the controller script takes in that input, tells the movement script that the user wants the player object to move to the right. The movement script then applies a positive X force on the player object, moving the object to the right, and also plays the walking animation. So it actually looks like the player is walking on the tiles himself. And then the player stat script is responsible for keeping track of the player's current position and the health during the playthrough. This is important for our save and load system that we implemented. So when the player saves the game, it saves its position and the current health that the player object has. And once the user loads back into the game, it'll spawns the player object back in the same position and with the same health that it was saved as. And then lastly, we have the player combat script. And what this does, it basically allows the player to be able to interact and fight the enemies in our world. And it basically determines whether or not the player object weapon hits an enemy's box collider or hitbox. And if it does, then it reduces the enemy's health, eventually killing the enemy once they run out of health. And then these are the 3 different enemies that we're actually able to create for our game. As you can see, we have 2 melee attack and then 1 range attack. And all these enemies are made up of a rigid body, a box collider, and an enemy script. And so what the rigid body is, it allows us to be able to apply real-time physics to the enemy objects. So this allows us to implement a knockback system for when the player hits the enemy, it knocks them back a little bit, showing the user that you actually did some damage to the enemy. And then and it also has a box collider, or people usually call it a hitbox. And again, this is used to detect if the player's weapon came into contact with the enemy object, and if it does, it'll apply the knockback to the enemy. And then lastly is the enemy script, and this is responsible for basically bringing the enemy to life. So the way we created our enemies is that they can only be in one state at a time. And when I say state, I mean an action that the enemy can perform. So, for example, walking is a state, and then being idle is a different state. And so the enemy script is responsible for changing the enemy's animations from one to another. And then so we have state machines for each of the enemies, and this allows the enemy script to change from one animation to another. So if you look, you can see each block, they actually represent a state, and then it also contains and holds the animation for that state. So if you look at the enemy states, we only actually have 2, one for the melee enemies and one for the range enemies. I know the boxes say ghosts, player detect, but it's the same exact model and design for the skeleton spear person. The only difference is they have different animations because they're different enemies. And then key differences from melee enemy and range enemy. In a melee enemy, you have a chase state, which is when after the enemy detects the player, he'll chase them, and then once they get in range to perform a melee attack, they will. And instead of a chase state for our range enemy, we actually have a dodge state. So once the range enemy sees the player, he'll actually jump back and then start performing its range attack. If you want to go back to the other slide. So you can see for the ghost example, it detects the player, transitions into the chase state, which then transitions into the attack state once the ghost gets close enough. And then for the skeleton archer, once this archer sees the player, he goes into the dodge state, jumping back straight into its attack state, drawing the arrow and firing it at the player. And then we also implemented an inventory system and interactable items. The interactable items can be picked up and used by the player, and to pick them up, it's with the E key, and then to use them, once they're inside the inventory system, there's a number key associated with each slot. And since our inventory can store up to 5 items, the keys that are associated with the slots are 1 through 5. And as you can see in the GIF, as once you press the key that has an item in it, it'll use that item. And our item that we implemented is a health potion. So the usage is just increasing the player health by 1 whenever they use an item.
Another key element of the game are the NPC and the notes. The notes contain a couple lines, usually relating to the story. If you piece them together, you could possibly form a narrative. The other key element is the non-player character. The non-player character contains a fair bit of dialogue that tells the player where to go to finish the game. The dialogue, however, is in a rhyming form, so whether or not you can decipher it is up to you. Both of these use a dialogue box. The dialogue box is composed of 3 parts: the dialogue manager, a dialogue trigger, and the dialogue canvas. The dialogue trigger is the first element. It is attached to the note or the NPC. If the player gets within range and presses the E button, it sends a message to the dialogue manager. It sends the dialogue manager the name and the sentences on the dialogue box. The dialogue box then is attached to the dialogue canvas, which rewrites the name and the text field of the dialogue canvas to match what it was on the dialogue trigger. Then when the player presses E again, it will either transition to the second sentence, or so on and so forth, or close the dialogue window. The game has 4 areas. The first area is the intro area, hence the name. Second is the city. Third is what we call the catwalks. And the last is the pit. The intro area is fairly simple. There's some difficult-ish platforming, a couple enemies, and a fairly welcoming design with some grass and some rocks. The second area, the city, has a specific theme that you could find out if you read the notes. It is a city. It has houses, it has skyscrapers, and it has branching paths that the player can walk through. However, it's an illusion of choice, as all the paths lead to the catwalks. Catwalks is the third area. It is a large open expanse that the player, if they fall, will take damage. When they take damage, however, they respawn on these large hanging platforms. In this area, you can see a small little hut with a light coming from it. This is where the non-player character lives. The fourth area is the pit. The pit has some of these huts too. All the lights are off, as no one is home. The pit is desolate. There is skulls, there is plants, and there is no enemies. In the pit is the end of the game. That's where the player has to go to finish. But I don't want to spoil too much, as some people here will be playing the game at a later date. Area creation. We used tile sets and sprites. Tile sets are on the right. As you can see, they are made up of 16 by 16 images. We use these, similar to kitchen tiles. By placing them on a grid, they are used to create images of much greater detail, as you could see previously. The sprites, however, are single images that are used in like a copy-paste format. The cathedral here is used, it is a huge image, about 15 by 20 grid tiles wide. Or other images that are used as sprites are candles, the player animation, the notes, or the health bottles. However, didn't all come easy. There were many difficulties along the way. including, for me, my difficult part was the dialogue system. Even though I was able to find help on the internet, it was not easy. It took me well over a week and a half, and it was a pain, to put it simply.
The difficulties I had was definitely the saving and loading system, trying to figure out the best way to save and load the players' positions and stats. Unfortunately, it took away most of my spring break, but I was very thrilled and excited to finally get it implemented and working. And then also the combat system and how enemies attack and players attack interact with each hitbox, and then calculating the health damage or the subtracting the health from the damage was very difficult to figure out and implement. And then so for future possibilities, obviously more is better for most cases in the game. So adding more items, something that we would like to implement later, if possible, would be like a magic attack where the player kind of shoots a fireball, and then having a certain amount of magical usage. So then we can add a magic potion where, like the health potion, it'll just increase the amount of magic uses that the player has, and also more enemy types. So we have about 4 areas in our game right now, and having specific enemies for that specific area would be really nice and cool to have.
Another thing we would like to add is boss fights. We had one planned, we were not able to get to it because of time constraints, but a few boss fights would make the game really pop out, make it much more interesting to the player. Another thing we'd like to add is more areas. A couple places in the game, I added stuff specifically to allow for further expansion of the areas that would allow us to add more areas in the future if we ever had time or motivation. And now, a demonstration. I'm going to give a big thank you to all of you who came to watch our presentation, and an extra big thank you to our capstone advisor, Shireen. With all her love and support this year, we were able to complete this. And without that, I don't think that would have happened for us.
Thank you so much, Shireen, and everyone that came to the presentation.
Any questions?